A brief overview of early vacuum tube computers. Although the vacuum tube was first invented in 1904, it was not widely used until around 1910. Broadly used in radio, vacuum tube usage increased dramatically during World War II, as radio transmission, radar, and other military uses greatly increased the need for even better and more reliable tubes. Early radios of the 1920s through the 1950s rarely had more than a dozen vacuum tubes. Early television sets similarly had an average of only 10 to 15 tubes.
Well, the tubes are connected to the chassis is connected to the picture tube is connected to the tuning dial connected to the cabinet, and the name goes on right here.
Contrast this with the first digital computers that had thousands, sometimes tens of thousands of vacuum tubes. There are numerous functions that vacuum tubes performed in early digital computers. A vacuum tube can also be used as a diode. A diode allows current to flow only in one direction. This can be used in devices to convert AC to DC power, convert voltages, or to construct a logic gate. A vacuum tube can be used as an electronic switch to represent the on-off conditions of a binary system. Digital computing relies on the power of millions of binary functions, thus making large numbers of vacuum tubes critical for large-scale computation. Tubes were also faster than earlier mechanical relays used in some computing devices. The technology of the cathode ray tube, or CRT, familiar in early radar equipment and television sets, was modified and used in the University of Manchester's Mark I in 1948. One of the world's first stored program computers, it utilized CRTs as an early form of computer memory, which became known as the Williams-Kilburn tube, after inventors Frederick Williams and Tony Kilburn. Broadly speaking, the electronic digital computers built during the 1940s up to about 1956 are referred to as first-generation computers. One characteristic of this first generation was a massive use of vacuum tubes. Among the notable examples are the first Colossus computer, which began operation in 1943, contained 1,600 vacuum tubes. The following two tables list a few of the early vacuum tube computers. The ENIAC, announced in 1946, was the brainchild of inventors John Mauchly and J. Presper Eckert, and contained over 17,400 vacuum tubes. The RCA Bismack computer, announced in 1956, contained 25,000 tubes. And there are many other examples.
This is where America's peace of mind begins. Around the clock, radar's electronic eyes watch the skies and report what they see to SAGE, Defense System of the United States Air Force. Here is a SAGE center on 24-hour alert. At its heart is a computer developed by a research team from MIT and IBM working with the Air Force. The SAGE computer speeds the information for decisions by man in our missile age.
In 1955, the US government's SAGE computer system utilized giant machines in various parts of the country, each containing nearly 60,000 vacuum tubes, as well as 175,000 diodes and 12,000 transistors.
Friend or foe, within seconds the Air Force will know. The officer fires a light gun at the target blip. This tells the computer to track the object. Now they ask the computer to calculate an intercept point.
Seen here is a very unique early vacuum tube computer called the Harwell Decatron. Built between 1949 and 1951 for the UK Atomic Energy Research Establishment, the Harwell uses over 800 Decatron tubes for memory storage. From 2009 to 2012, it was restored to working condition. Today, it has the distinction of being the world's oldest working programmable digital computer. It resides at the National Museum of Computing, located Bletchley Park, UK, the site of the famous super-secret computing and code-breaking projects. Today, the museum uses the computer to teach school children about computers. Seen here is an interesting configuration known as tube and cage. Tube and cage units were used in the 1949 Remington Rand 409 computer. The 409 was later sold in two models, the Univac 60 and the Univac 120. Shown here is a Univac 120 with approximately 800 tubes. It cost $90,000 in the late 1950s. Over 1,000 Model 60 and 120 were eventually produced. Leo 1, the first business computer. In October 1947, J. Lyons and Company, a British catering firm famous for its excellent tea shops, took a bold step in the commercial development of computers. They created the Leo for Lyons Electronic Office. Released in 1951, it became the first business computer and ran the world's first regular routine office computer job. Leo uses 5,936 tubes, or valves as they are known in the UK, plus another 400 in peripheral equipment. It used 64 mercury tubes for storage. Each memory tube was over 5 feet long and weighed over 1,000 pounds. Oscilloscopes were used to monitor contents of memory storage.
Manufacture of the electronic circuits begins with small packages carrying a few valves assembled by hand. Every soldered connection is inspected for good workmanship and freedom from dry joints. The packages are then incorporated into larger units. The larger units are electrically checked connection by connection against the designer's drawings. Thus, each part has been checked mechanically and electrically before it goes over to a new Leo. At the new Leo, individual assemblies are set together for functional electrical tests to prove that the performance of each circuit conforms to specification under normal and marginal conditions. And between office jobs, night or day, it does calculations for a wide variety of interests. For an hour a day, Leo belongs to its engineers for maintenance and testing. The voltage, normally kept to the operating figure, is made to fluctuate. Any valve or other component operated in such conditions is certainly fit for another 24 hours useful life. And if it cannot, then now is the chance to change it. These are only a few examples of the wide range of work undertaken by Leo.
Leo had a speaker installed for programmers to listen to sounds generated as it calculated. Programmers used this speaker to generate some of the first computer music. Leo occupied 5,000 square feet and used 30,000 watts. A unique modular design provided easy access to components during equipment failure, including tube replacements, which at times reached 50 tubes per week. Leo Computers Limited, formed in 1954, successfully produced many Leo models. The following slides list 13 of the tube types found in the UNIVAC 1 and show some examples. The UNIVAC 1 was 25 feet by 50 feet in length, containing nearly 5,600 tubes, 18,000 crystal diodes, and 300 relays. It utilized serial circuitry, 2.25 MHz bit rate, and had an internal storage capacity 1,000 words or 12,000 characters. This is an original UNIVAC tube chassis, nearly 2 feet long, The Whirlwind computer used over 32 different types of tubes, about 4,500 tubes in all. Tube types found in the Whirlwind were also present in the IBM Sage computers since the technology was similar. Manufacturer names. It was a common practice for factories to source tubes from each other and relabel them. Some tubes made by Tung Sol were sold as RCA tubes. Many RCA-made tubes were sold under the Sylvania label. Sylvania often made tubes for GE, and GE in turn made tubes labeled IBM, and so on.